All right, so welcome back to the science demo table. Last one of the season. Oh my gosh. Okay guys, so we're gonna do sort of a classic science experiment called elephant toothpaste. It's maybe something you guys have done before. Does this ring a bell?
No.
Okay,
Nope,
cool.
never
Hopefully
done it.
it'll be neat. So it's sort of a combination of a chemistry experiment, but it's also biology related, or at least it can be, because we're gonna use yeast, living yeast, to sort of help us with this, okay?
That's dark.
It is kind of dark in the sense that we're going to kill all the yeast to make this happen, but there's lots of them.
Sorry, yeast.
Sorry, yeast. Okay, so I have 3 beakers, so we're gonna do 3 rounds of elephant toothpaste. I thought, since it's the last show, I wanted to give each of you a chance to make it happen.
Wow.
And we'll vary a little bit with each. So we've got 2 cylinders that are the same volume, 1 liter each, and then we have a 500 milliliter cylinder with a tapered spout. And so hopefully we'll get a little bit more explosive force out of the tapered spout. We'll see. It's not super explosive done this way, and I'll sort of explain why, but we will get there. So what we're going to be doing is we're going to mix hydrogen peroxide with yeast. Just from the name, hydrogen peroxide, could anybody guess what the formula of hydrogen peroxide might be?
Obviously, it's hydrogen over oxide.
Well, it's kind of like that, right? Like miles per hour,
Yeah.
right? So there, for every hydrogen,
Yeah, for every oxygen, aren't there? Well,
so it's water.
yeah.
What is water's formula?
H2O.
H2O. And
That's
H2O is
cool.
very stable, right? We got it all over the earth. It stays in its form. So hydrogen peroxide adds 1 oxygen to the formula H2O, making it H2O2. Does that make
Oh, I
sense?
see. And then the
I was gonna
oxygen,
say
the hydrogen's
HO.
on the end.
HO.
That makes
The O's double bond, right? Or not double bond, or
Yeah. And actually, the bond between the 2 oxygens is really unstable, and that's actually what makes hydrogen peroxide really useful to us. So H2O2 is fairly unstable. It joins up with, so oxygen, 1 extra oxygen will join up with an H2O molecule to make H2O2, but then that other oxygen would really like to jump off and join another chemical. So what will typically happen is H2O2 will break down to H2O water and O2 gas, oxygen gas. So that happens inside of bottles, but very, very slowly. We're going to speed up that reaction by using yeast as a catalyst. Could any of you guys explain what a catalyst is, or
Something that causes
Incites
change,
the
right?
difference.
something that causes change, incites the difference? Those are like great English definitions.
Speeds it up.
Speeds up a
Yeah.
reaction is what we're going to say in chemistry usually. And we're using not a chemical catalyst, well, it is a chemical catalyst, but it's a biochemical catalyst. So it's an enzyme produced by the yeast. So what we'll do is we'll actually heat the yeast up a little bit, put them in warm water, which will get them living for just a moment. And they'll start producing this chemical called catalase. And catalase is a catalyst, just like it sounds like. It's a protein that will speed up the reaction, breaking down H2O2 into H2O and oxygen. Does that make sense?
Yeah.
Okay, cool. So, Antonio, I'm gonna have you go first.
All right.
All right, so you need to get a ½ cup of hydrogen peroxide, pour it into there. Now it's relatively safe stuff, but try not to get it on you
right.
or in your eyes.
How it again, my
I don't know, these things
Maybe
happen.
we should dye your hair blonde while we're here.
Yeah, there you go.
Sure. I'll get all the ladies like that.
So we had to just finish off that bottle. I was mostly done with that guy right there.
Let's finish off a little more. Get those drips.
I got a fresh one for you. Gotta
right.
get the last of that. Ba-doom.
Half a cup, right?
½ cup.
Well, if it's like slightly more than half
And while
a
that's
cup.
going on, Nate, will you get one of those plastic cups going with a tablespoon of yeast and just a little bit of warm water from the kettle there?
1
Okay,
tablespoon.
Antonio, go ahead and pour that into your large
All
beaker
right.
there.
Cheers.
So just a little bit of water? Oh,
Yeah, so just enough water to kind of cover the yeast.
all right.
And then if you'd use one of those spoons to stir it around for us for just a minute.
Will.
Antonio, we're going to add 2 things to the hydrogen peroxide. So the first thing we're going to do is add just a drip of
enough?
soap.
Probably a little more.
Little more, Nate.
Okay.
So go ahead and just add just a drip of soap in there.
All right. Soap.
And soap is useful in this reaction because soap has one end. Soap molecules have one end that is polar, that has a magnetic force, and one end that is nonpolar. And what that'll do is it'll just help to encourage the breakup of our H2O2 molecules. What we really want to do is have these H2O2 molecules break down as quickly as possible to generate as much foam as possible, because it's the foam that's sort of the exciting part of this experiment. And then
just gonna
last
keep
but not
stirring
least,
this up,
you just
or-
keep stirring over there. Is it pretty liquidy?
Should I put more?
More water. More water.
That looks delicious.
Yeah, you want to try some?
Sure.
Okay, so Antonio, last but not least, you get to choose the color of your foam.
Can I like mix them together, make some crazy colors?
Go for it, Antonio. It's the last
Okay.
show. You do anything.
All right, so we got red, and we got yellow. If I remember, wait, no, I can do purple. Oh my God.
There you go. Because red.
Oh, you stole my idea. That's what I was gonna do. I'll just have to do a different shade of purple.
That's fine.
Sure.
We can do it. We can do it that way.
How many drops?
Just a very small amount.
Like one drop?
Yep. 1 drop of each would be perfect.
Can you explain the science of it slowly spreading through the water?
So that's just diffusion. I'm not going to get into that right now.
But it looks cool.
It does look beautiful, doesn't it?
Yeah.
All right. So then we'll just kind of shake this guy up to get it mixed up. There's the color that we'll hopefully get from the foam. Nate, how liquidy is that?
Very
Oh, this.
Yeah.
I was like, that's very liquidy.
Oh, yeah.
That's what I thought.
That's
too.
super liquidy.
I was
isn't
like,
it?
very.
But the yeast makes sure
Yeah,
it's
yeah,
really
it's
liquidy?
pretty
Okay,
liquidy.
so the
Is that
yeast,
good?
yeah,
A
that's
little clumpy.
perfect. The yeast have had a little bit of time in there to activate themselves and start producing this chemical catalase. Now, when we get cuts, right, we pour hydrogen peroxide on our cuts. Our cells produce catalase also. And the breakdown of H2O2 to H2O and oxygen is an environment that releases so much oxygen that it's actually deadly to a lot of bacteria. So that's one of the reasons that we clean cuts out with H2O2. So we're going to be seeing sort of a large-scale version of what happens inside our cuts.
Smother it with oxygen.
Right.
So we're being like doctors right now.
We're being like doctors right now. All right.
Call me Dr. Antonio.
Oh, I've always wanted to call you Dr. Antonio. Okay. So why don't you, Antonio, you can go ahead and pour that yeast right into the beaker there.
All right, all
And
of
just
it?
do it all of it, and just do it quickly, and then it's not going to explode too intensely. But
Okay. All right, right before I do, I just want to note you did not call me Dr. Antonio.
oh, Dr. Antonio.
There you go.
Okay, come on, baby. Oh God.
It's doing it.
Yeah.
Doing it. So what we're going to try to do, so okay, this reaction is not going as fast as I would have hoped that it will. Now it should just continue to go and sort of squirt out into this toothpaste-like tube, which is why it's called elephant's toothpaste. But for the second one, we'll actually increase the amount of yeast that we use to see if we can increase the rate of reaction.
Okay.
Oh, here it comes.
So we're going to kill more yeast. Perfect.
And I think we need more color too.
Yeah, I agree with you, Becca.
I
My
ended up
purple's
picking
gonna
one.
be better.
Oh. Now, there's another chemical that you can use to do this, potassium
cool.
iodide. Now, sadly, I was not able to get my hands on liquid potassium iodide before this experiment. But hopefully for season 2, we're going to redo this with potassium iodide. It's a much, much faster reaction. But there you go, elephant toothpaste. Very exciting.
put a little green
Go ahead,
in there.
go ahead. Why not? Why
Yeah.
not?
Boop. There we go. I don't think the audience can see that all.
We can.
Okay, so while that elephant toothpaste is going, Nate, I'm going to have you do the next one here.
All right.
So Nate, let's actually increase. You can use a clean cup. Let's increase the amount of yeast that we're using. So go ahead and do 2 tablespoons of yeast and then even more water.
All right.
And Antonio's going to get you a half cup of hydrogen peroxide here.
Gotta try to be useful. It's like if I get paid and I don't do any work, then what's it really for?
That's exactly right.
Better leave some yeast in there for me to
do a
make
little
my
bit- I'll
elephant
do a little bit more.
toothpaste.
All right.
Nice. Nate, I would do even a little more than that.
A little bit
Honestly,
more?
A little bit more water.
Yeah, it's gonna.
Think that's all right?
It's a little watery.
Okay, well, Antonio, why don't you pour his hydrogen peroxide in there for him?
Nope, you're right.
Yeah,
water.
yeah, some more water.
Never mind.
All right, Becca, what do you think about colors for this one?
It can't be purple because mine's going to be
'cause
purple.
yours is gonna be
Let's go.
You wanna go orange?
Yeah, that's
Okay.
what I'm thinking.
It's actually kind of
Antonio?
hard to stir.
More this time. Let's do 2 of each.
Are we doing that for this one? I wasn't listening, I'll be honest. I have listening problems. It's not you guys, it's me.
Nice.
6 drops. Each. Getting crazy with this.
Why not? Why not?
Why not? I agree.
All right. Nate, how's that yeast looking?
It's a little clumpy still.
A little clumpy still?
Yeah, it's actually kind of hard to stir. with
Yeah,
that spoon.
yeah, it does clump really quickly.
Yeah.
That's not something that I'd really thought about, but maybe
A
next
whisk.
time I do this, I'll try to think, yeah, maybe a whisk would be the way to do it. Or
Are
add
you
in.
putting soap in this one?
Did you not put any soap in? Yes, please put a little bit of
All right.
soap in.
All right, now we got some good liquid going.
Yeah. All right.
A little more soap. You gotta get crazy with this.
Now, something that I'm not sure about is, so when you're making like bread, or you're using yeast for different kinds of baking or fermenting, you would let it sit for a while to really get going and to get the colony growing. And that might actually mean that the longer you waited, the more catalase you would produce, which might speed up the reaction. Of course, we don't have that much time here, but that would be something if you wanted to experiment with this at home and try to change something up, you could look at the rate of reaction with yeast mixed instantly, and then yeast that's been sitting out for 5 minutes, and then yeast that's been sitting for maybe half an hour, and see if there's any kind of difference.
Yeah, that would be really interesting to just change the factors individually to see exactly.
If
how
we
it
need more time, we can just make a time machine. I mean, we have soap.
We have soap. What more could you possibly need? Nate, go right ahead, dump that in there.
All right.
Hopefully we'll get a slightly faster reaction here. Come on, elephant toothpaste. Oh yeah.
Oh yeah.
Oh yeah.
Whoa!
That's a little more what it's supposed to look
That
like.
looks gross.
Yeah, right? Oh.
And there's the orange.
And it's nice and orange.
You don't want to use that for toothpaste?
Oh, that's
Antonio?
beautiful.
I mean, I'll use it for an elephant's teeth.
So this is
And I
also
need like a giant novelty toothbrush too.
Of course.
okay, so the last one, I'm really not sure what's going to happen with this one, but hopefully we'll get a little bit of explosive force out of that thin tube. Okay, so Nate, would you get the hydrogen peroxide going for Becca?
I changed my
All right.
mind on the color, by the way. We're gonna do.
Oh my gosh,
We're gonna do a blue green,
A blue green.
A blue green,
green.
like an
Am I
aquamarine,
Like a
doing another half
turquoise.
cup?
like a turquoise,
like a
Half a cup?
turquoise.
half cup.
I'll just hold the soap.
So we're going to use the same ratio that we did with Nate's, since that seemed to be the most effective.
Ooh.
So we'll do 2 tablespoons of yeast.
Some of that yeast that's already.
And
in
but
there.
at this point we're reducing volume, so we should get again a pretty.
Pretty good reaction.
I'm hoping that it'll
This
happen
is gonna
fast
be
enough.
the best one. I know it.
What would be cool is if we got a little bit of lift out of that spout, but I'm not quite sure it's
Well,
going to
it'd be
happen.
not cool if we got a lot of
Yes.
lift out of that.
Right,
spout.
right. I would be probably in a lot of trouble if I got elephant toothpaste all
Let's
over
see
the
what
lights in the
happens.
studio. But it's the last show, so
It's
there
your
water
fault
again?
if
blame
anything.
it on me.
Definitely your
I
fault.
just
Same amount of
didn't
water,
know.
roughly, that you did last time. All right, so Becca, here is your
Oh,
hydrogen
might be too much
peroxide.
water.
Go ahead and
Okay.
pour that in.
You put in too much water.
Oh, I think I put in too much.
All right, and you can do your color
There's
mixing.
no such thing as too much.
All right, good to know.
There's when you're diluting.
Too much water? Nah, I think it's okay.
I'm thinking.
It's still clumpy, so.
Nice, lots of blue.
Okay, wait.
A lot of thoughts going into the color right now, I can tell.
That's good. That is good. Okay.
Look at that bubble.
That's gonna be great.
And maybe, yeah, one other thing to just mention is, so like the soap and the yeast are helping to provide a little bit of structure for the foam, but all of the gas that we're seeing there is just oxygen gas that's being produced. So consider that from that amount of liquid, everything that we've seen here, all the bubbles are just oxygen gas. So it's really a significant amount of oxygen that's produced when this reaction
I mean,
occurs.
it's a safe experiment too. You're not creating anything.
It is pretty safe. Hydrogen peroxide, again, it can bleach.
bleach
It
stuff,
be,
but
you know, so
not-
definitely if you're going to do this at home and you're a
need
young
soap.
person, do it with adult supervision. But as experiments go, this one is relatively safe, I would say. Thank you for interpreting what I said with hand gestures.
Is
Yeah.
that enough soap?
That's perfect. Okay. You ready?
So we doing this? How are we
Well,
doing
what am
it?
I doing with this? So I'm gonna pour it
Oh,
in
yeah,
and then-
sorry. So yeah, let's have Nate do the pour, and then you got to get that cap on
All right,
fairly
ready?
quickly,
teamwork,
Becca.
teamwork time.
3, 2, 1. Oh!
All right, that worked. Well, we don't have to clean this up, right?
Oh, God. Well, that was a little bit worse than I expected.
Or better,
Or better, depending on your perspective.
depending on who has to clean.
We have to
You
clean
didn't
up a
notice
lot.
I did not notice.
Okay, well,
Oh,
it seems like
geez.
it's mostly on the floor and not
On
And
my
Becca's face.
On my face.
and
on my
Becca's face.
Yeah,
Oh,
yeah,
man.
yeah.
That is fantastic. Well, we're going to end it here so Becca gets a chance to clean herself up and we can kind of wipe the studio down before our next segment. But thank you so much for joining us. We'll see you back at the Homework Hotline desk.
Remember, it's safe.